Today we will proceed our existing topic, that is dynamics of rigid body. Under this topic we already get the position of center of mass, and we learn about a bit about what is center of mass. Now we get the derivation of two particle system. Now we will talk about a two particle system in nature. Okay, so there are so many substances and materials in the nature. Okay, and they have the atoms. They are the combination of some atoms, molecules. Then what happens if element has only two atoms? In that particular case, it makes a dipole, and we will learn about the two particle system in nature. So, in two particle system in nature, relative motion of system of two particles or two bodies under center forces can be analyzed in terms of motion of a single imaginary particle or body. The effective mass of this particle or body is called the reduced mass of two particle system. Now we can consider Earth and Moon, proton and electron in hydrogen atom. Two atoms of hydrogen molecule and positronium systems as two particle system under the influence of mutual interaction forces and free from external forces. So two particle system in nature, for example, Earth and Moon, proton and electron in hydrogen atom, proton, electron, hydrogen atom, two atoms of hydrogen molecule, two atoms, two atoms of hydrogen molecule, and positronium systems as two particle systems, as two particle systems. Under the influence of mutual interaction forces and free from external forces. Under the influence of mutual interaction force and free from external forces. Now go for the reduced mass of two particle system. Here is the two particles, namely M1. This is the position of they apply forces on each other. The above figure shows the two particle system of masses M1 and M2. Their position vectors related to origin O are R1 and R2 respectively. Suppose only mutual interaction forces are acting between the particles. Only mutual interaction forces are acting between the particles. F12 is the mutual force. F12 is the mutual force. Center force. We can also know that this is a center force on particle M1. On particle M1 due to M2. Due to M2. And F21 is the mutual force That is again a central force on M2 due to M1. Okay. Now equation of motion of the particle of mass M1 will be equation of M1 into dr1 square upon dt square, that is the mass into acceleration only, or d square r1 upon dt square is equal to f12 upon m1. This will be the acceleration in terms of force and mass. Now, equation of motion of the particle of mass m2 f21 d square 2 upon dt square is equal to f21 m2. This will be equation 2. Now, according to Newton's third law of motion, according to third law of motion, forces are equal and opposite to each other. So, M2 is equal to minus F21. And as the magnitude of forces are same, let us suppose this will be F1. So, the acceleration will be d square r1 upon dt square is F upon m1. Similarly, d square r2 upon dt square is equal to m2. Or, on reducing both the equations, we have d square upon dt square, that is r1 minus r2 will gives you f factor upon 1 upon m1 plus m2. So suppose this will be the equation 3. Now if r12 is the displacement vector of first particle related to the second, then r12 is the displacement vector of first particle related to second. r1 minus r2 is equal to, let us suppose this will be the equation number 4. By equations 3rd and 4th, we can write d square r12 dt square is equal to m1 plus m1 m2, or mu d square r12 dt square is equal to, so these are the equation and 6. So where what we can write mu will be m1 m2 upon m1 plus m2. This is called a reduced mass of two particle system. It's called a reduced mass of two particle system. Reduced mass of two particle system. This is the equation of motion of a single particle, a body of mass mu, whose position vector related to origin is r12. Therefore, in the two particle system, any problem of two particles with position vectors say R1 and R2, which are in relative motion due to the mutual interaction forces, can be replaced by a single particle problem whose position vector will be R12. That means a two particle system problem can be replaced by a single particle problem whose reduced mass is given by mu, where mu is equal to m1 m2 upon m1 plus m2. The next topic, next lecture, we will get some examples of the two particle system structure, like system of Earth and Moon, and reduced mass of phlogiston, diatomic molecules, and reduced mass of hydrogen atom.